In addition to the metals with nonmetals, and those are broken down into fixed charge metals and variable charge metals, there is another set of compounds that only involves nonmetals, and they call those molecular or covalent compounds. And these are compounds without ionic charges, so no positives, no negatives. And here's just some examples. So the one in the upper left there, nitrogen dioxide, carbon dioxide to the right of it. Lower left corner is that organic molecule, methane, CH4, that we'll talk about more in Chem 222. And then there's also boron trichloride. These are all covalent molecules. And if you look here, these all involve nonmetals. There's no iron, there's no sodium, there's no chromium, there's no uranium. These are all nonmetals with nonmetals. And remember, hydrogen can kind of play the field. It can act both as a metal and a nonmetal. Naming these is pretty easy. It's literally just the first name followed by the last name, and the formula is important. Like CO2 is always CO2, it's not O2C. The second atom listed gets an IDE ending, so that means it's the negative side, all right? And you use a Greek prefix to tell how many atoms there are. So you can see in these examples, it's nitrogen dioxide. So 2 oxygens and 1 nitrogen. Oxygen is listed second for a reason. You should never write O2N, all right? So the O gets the IDE ending, nitrogen dioxide. And carbon dioxide would be CO2, 1 carbon, 2 oxygens. Boron trichloride, boron and 3 chlorines. Methane is kind of is a naming system we haven't looked at. You could call this carbon tetrahydride. Carbon first, tetra is 4, hydride is next. The important thing here is that these Greek prefixes, which I think you're going to find are pretty easy to use, only for nonmetals with nonmetals, all right? Do not use them with metals and nonmetals. Ionic compounds have those positive and negative charges. None of these compounds, like CO2, BCl3, etc., none of those have positives and negatives. So nonmetals with a metal is ionic. Nonmetals with nonmetals are covalent, and you can use Greek prefixes. Do not use Greek prefixes if there's a metal present. Here are the Greek prefixes. They may be familiar to you, they may not be. We're going to use these quite a bit, so make sure you know them. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, etc., etc. We'll use those quite a bit in this section. But again, only use these if there's nonmetals and nonmetals. So you can hopefully see it's going to be really important to know where things are on the periodic table. And you can always use a periodic table when you're studying, taking exams from me, even if they're in class and stuff or quizzes. I love it, but make sure you've got a periodic table next to you. Let's find a name for N2O4, all right? And what I would do is I'd first try and figure out, all right, is there a metal present? And both nitrogen and oxygen are in the upper right-hand corner of the periodic table. They're above the metalloid line, so they're both nonmetals. So this is now when we can use Greek prefixes. If the first atom listed has more than one, you do want to put in a Greek prefix. You always put a Greek prefix in the second atom, but the first one you only do if there's more than one atom. So because there are 2 nitrogens, that would be dinitrogen. There are 4 oxygens. 4, you can see there is tetra. We're going to change oxygen to oxide. So the answer here would be dinitrogen tetraoxide. The first one would be an incorrect name. Nitrogen oxide, you'd want to have a Greek prefix next to it, because right now we don't know if this is nitrogen monoxide, nitrogen dioxide, so that's a bad name. The second one, nitrogen dioxide, NO2. All right, so we could know that. Now, the next one, quad, is not a Greek prefix, so that would be a bad name. And the last one, tetraoxygen, no. The last element listed always gets an IDE ending. You would never use just oxygen. Notice how nitrogen dioxide, NO2, is different a little bit than dinitrogen tetraoxide. You don't call nitrogen dioxide mononitrogen dioxide. If the first one is by itself, you omit the mono. So NO2 is nitrogen dioxide. But if there's more than one, like N2O4, then even that one gets a Greek prefix, dinitrogen tetraoxide. Or tetroxide is fine too, but officially tetra. Okay, so kind of as an overview, there's three types of compounds. There's fixed charge metal plus nonmetal. Those are ionic compounds. Those do not use Roman numerals or Greek prefixes. So Al2O3, aluminum is one of the stairs. Oxygen -2, nonmetal. Aluminum oxide would be the name of that. There's also variable charge metal and nonmetal. These are also ionic bonding, but with these now you do want to use a Roman numeral. You don't need a Roman numeral with the fixed charge metals because everybody knows, or at least the hip chemist knows, aluminum's +3 and oxygen's -2. But with the variable charge metals, if you just said iron oxide, you might go back and pick out FeO instead of Fe2O3, and there's actually several other possibilities. And you've got to know which one to use. So Fe2O3 is iron 3 oxide. There are 3 -2 oxygens, so the oxygens have a total of -6 charge. The 2 irons have to balance that with a +6. That means each of those irons is a +3. So Fe2O3 is iron 3 oxide. And again, it's important to use the Roman numerals because there is, for example, an FeO. That compound is iron 2 oxide, and you've got to know which combination of iron and oxygen you're in. Remember the H2O versus H2O2, okay, one extra atom can make you die, etc., etc. Finally now, there's nonmetal and nonmetal. These are covalent bonds. They're not as strong as ionic bonds, but they are more flexible. And covalent bonds are essentially the types of bonds that life uses, all right? And these guys use Greek prefixes. The second atom gets an IDE ending, and it's important. The ordering is important. So P2O3, diphosphorus trioxide. There's also a P2O5, which would be diphosphorus pentaoxide, etc., etc. These ones you'll use Greek prefixes. Now again, Greek prefixes for nonmetal plus nonmetal only. Roman numerals for variable charge metal plus nonmetals only. Fixed charge metal and nonmetals don't get anything.